Hey, what's going on, guys? Let's do this problem right here. The question is asking 2.5 kilogram object on horizontal frictionless surface attached to a spring with spring constant of 1000 Newton per meter. Initial displacement is 50 centimeter and the initial velocity is 10 meter per second back to equilibrium position. And the first question is asking what is the frequency. So in this case, to find the frequency, since its mass and spring constant are related, I can use this equation, that is F is equal to 1 over 25 square root of K over M, right? That's what I'm going to use right here. And here if I substitute, this is going to be 1 over 25 and K value that's given right here, that's 1000 Newton per meter, and I'm going to substitute that one right here, Newton per meter divided by the mass, that is 2.5 kilogram. So if I divide this one, I get this is like 2.5 times 4, like it's 400, right? So it's going to be 400, so it's going to be 20 over 25, and that's going to be equal to 10 over 5 hertz. And if you simplify this one, if you plug this one in the calculator, you will get 3.18 hertz. And that's the answer for the first question. So let's do the B part. So B part is asking for the initial potential energy UI, and then in a spring, potential energy is expressed as half k x square, and here we have constant that is provided, initial displacement also provided, so we can find this one. Half k is 1000 Newton per meter. 1000 Newton per meter multiplied by x square. This is 50, but this is in centimeter, so I have to convert in meter. This is going to be 0.5 meter square, and that's going to give us 125 joule. So this comes out to be 125 joules. So let's go to the D part. Initial kinetic energy is half mv square. So half m is provided, that is 2.5, and then v square is going to be 10. Here they have given the initial velocity, that is 10. So 10 square, that's going to give us 1000 times 100 times 1.25, that's going to be 125 again, 125 joule. And the next question is asking to find the amplitude. So amplitude, we can do one thing, like total energy. So in this case, total energy, if we add the initial energy, initial kinetic energy and initial potential energy, that's going to be total energy, right? This is equal to Ki plus Ui. So that is total energy, and that's going to be equal to maximum potential energy. That is, maximum potential energy occurs when it is in amplitude, because at amplitude is maximum height. So the maximum potential energy U max is equal to half Ka square. So this total energy can be equal to this one. So here what I can do, if I add this together, 125 plus 125 is equal to 250, right? So 250 for this one, 250 joule. So 250 is equal to half K, that we know, 1000 times A square. Therefore this one cancels, 500, and here I divide the 500. A square is equal to 250 over 500, and this is equal to 1 over 2. So this is going to be, A is going to be equal to 1 over square root of 2, and let's see what that gives us. That gives us 0.707 meter, and if you convert this one into centimeter, it's going to be 70.7 centimeter. And that's how we do these kind of problems. I hope you guys like this video. See you next time.